Hello, everyone. Thank you all for joining this exciting session, which is an introduction to the cloud and best practices focused on the actuarial and finance function. So we have a lot to speak about today, but before we get into it, let's introduce us, the speakers. So I am Vikas. I am a principal at Oliver Wyman, and I have a technology background, but I also am a credentialed actuary. And so with that experience, primarily for the last decade, I have focused on helping insurers transform. And over the last 6 or 7 years, that has been primarily focused on actuarial transformation or actuarial modernization efforts. And as you know, at least today, modernization within life insurance companies does mean moving to the cloud in a lot of cases. In a majority of the cases, that's what it means. And so that's why this topic should sound very interesting to you. Before we move ahead, I'll also let Michael introduce himself.
Yep. Hi, my name is Michael Hoffbeck, and I'm a second-year analyst at Oliver Wyman. Like Vikas, I also have a technology background. I went to school for computer science, and I've also primarily worked on actuarial transformation. So I have a lot of experience in different softwares, but also working with cloud technologies. And over the past 2 years, I've been able to gain a lot of experience working with cloud technologies. So yeah, I'm excited to share some of the things I've learned with you today.
Awesome. Thanks, Michael. So let's move on to the agenda. So as I was saying, this is an introduction. So we'll start with a problem statement as to like, why do we even want to move to the cloud? What is the value of moving to the cloud? What are the current issues? Then we'll get into some basics of certain concepts, certain terminology as we talk about the cloud. Then we'll get into the meat of the discussion, which is showcasing how things look like on the cloud versus how they look like today using legacy tools and solutions. We'll then make it real by showcasing a demo of an actuarial financial reporting solution that has been created and is created on the cloud. And then we'll finally finish by talking about where is the industry today as it comes to cloud adoption. And of course, we are live in the chat. So as we go through the session, please ask questions and we'll be able to answer your questions live. So with that said, let's get into the first section. So problem statement. So we have heard of, we generally, like as we transform, we always hear about certain issues that companies have. And these are like certain key themes, or you'll see quotes on the left-hand side. That's sort of like talk about key themes when it comes to issues today. So the first one is around, decision making. For certain large companies, it takes us as much as 3 months to go through a forecasting cycle. A lot of that is related to how fast can actuaries produce results from their models, and what that, I mean, 3 months just to run a forecasting cycle, and on top of that, if you wanted to do a what if analysis, it takes maybe a few weeks more. So decision making today is not based on current data. There is always a lag in that decision making. So that's one problem. Another problem is risk of financial misrepresentation in your financial statements. Like there is a big risk of material weakness in controls, especially as life insurers use Excel for reviews and approvals. Since it's manual, there is a big possibility of making errors and not catching them. So that's a general theme, as well as just the third one is like in terms of operational inefficiencies across business units or functions, where we see that as you go from actuarial to finance to investments to operations, everyone has a different way of doing things. And even across business units, as you move from retirements to life to annuities within the same company, again, everyone has a different way of doing things, not in terms of just having a single source of data. Everyone has their own way of managing their data, but everyone also has their own way of managing business processes, business logic, data pipelines. So, how does the cloud actually like help with that? We'll get into that discussion, but before we get into that, just on the right hand side, you'll see a word cloud, where we just asked an audience what word comes to your mind when you think about modernizing around data and technology, and you'll see cloud as one of the bigger words in there. And a lot of the other words are related to data. We are not discussing data specifically today, but data is a very important part of the cloud. The cloud provides compute, it provides a way to manage your data, and it provides a lot more. So those were the key themes in terms of problems. Now here we talk about the value of the cloud. So going from left to right, you'll see increasing value, where there is very little value when you're managing files locally. And as I was saying earlier, if files are managed in disparate way across functions or business units, there's not much value to that. Now, as you start moving right, if you start managing data in Microsoft SQL, in MS Access and Microsoft Access, you're able to like write queries, right? And sort of manage a local database. So slightly more value. But as you move to the cloud, you can use the cloud just as a place to store your data. So that's the cloud-based SQL DB. There is some value to that since you get faster compute. You get a way to store and centralize your data, and you might be able to make it more cost effective as well. But that is also not much value. The real value at the end comes when you're able to connect everything together on a centralized platform. So, for example, what if your actuarial data, your finance data, your investments data, and your operation data were on the same centralized cloud? In addition to that, what if your business processes for each of those functions were also on the cloud? Then each of those functions and each of those business units could harness each other's data, could harness each other's business processes, could harness shared functions on the same platform. Since everything is on the same flat platform, creating those connections is very easy, and that's where the power comes in, where everything is connected, and therefore like you're able to really make you're able to gain benefits out of that value. One example to illustrate, not an example, but almost like an analogy to illustrate that is a law called Metcalfe's law, where the value of a network is exponentially proportional to the number of nodes on the network. How does that relate to this? If you have, as I was saying, if you have different functions or different business units on the same cloud and they can talk to each other, then the value that comes out of that is exponentially proportional to the number of such business functions or the number of such business units that you put on the cloud. It's called Metcalfe's law. Go and read it offline. Won't get into the details of it, but it's sort of like proportional to n squared, where n is the number of nodes. So that's where the value comes in. Let's now move on to start and explain certain basic concepts and certain basic terminology on the cloud before we get into some more details. So what is cloud computing? Cloud computing really is you're transferring how you carry out any function. Let's say you were using Excel and you have formulas in Excel, or you have a VBA macro on Excel. Excel is actually using your local laptops or your local machines CPU to actually perform that operation, right? So the compute is your local machine. In cloud computing, you're transferring that compute, that operation to the cloud, where the cloud is backed by CPUs, GPUs to perform that same operation. And it can be much faster because your local machine has limited capacity, but on the cloud, you can scale and increase your compute based on your need, and you can make processes much faster. And since on the cloud, it's managed either by a company like Microsoft and Azure or AWS or Google Cloud, they're able to manage economies of scale and make it much more cost effective for you. So cloud computing is about performing operations, performing any kind of operations, whether it's an actuarial calculation or transforming data. You want to do that on the cloud to make it cost effective and to improve performance. Now, cloud service models, that's the second one over here. There are three ways you can think about how you can implement things on the cloud. So the first one is infrastructure as a service, which is you just think of the cloud as compute. That's all you're thinking about it as. Like you just want to run your data on the cloud, you want to run your model on the cloud, and that's it, right? Platform as a service is when you use the cloud more as a concept where you can perform a lot of your company's operations on the cloud. So you're not just thinking of it as where I can store my data and run my models, but you're thinking of it as I'm going to use Microsoft Azure's data factory to create a data pipeline. I'm going to use Databricks to do post-model processing, or I'm going to use AWS Glue to create an infos extract. So you're harnessing the cloud as a platform, and you're basically using their services to perform business functions. That's platform as a service. And you're building your own solutions on the cloud, right? You can build your own post-model processing solution. You can build your own financial reporting solution on the cloud. That's platform as a service. Software as a service would be where on the cloud, there are already softwares that are use case specific, that are already built on the cloud, and you're just using those services instead of creating your own solution. So we don't need to get into the details of SaaS, but platform as a service is the key message here. Cloud tool integration. So cloud tools specifically, like if you're on AWS or on Azure or on Google Cloud, the services they have, let's say to create data pipelines or to write Python code, write SQL code, some of the services are like already natively connected to each other, or they have ways to natively connect to each other. So you can leverage those tools to integrate between services. And flexibility, I think, is something I already talked about, but it's the ability to increase or decrease, as an example, compute or memory on the cloud. So the thing is, on the cloud, you have like various modes of paying for the services. You can have something that's dedicated and a certain memory size, or you can make things more dynamic in nature, where you say, okay, I will only pay as much as I use, and I want a real-time ability to increase the compute if I suddenly have a large load that I want to operate on. So there is a lot of flexibility you can manage on the cloud. You just have to set your settings on the cloud to be able to create a balance between performance and cost. So those were some introductory concepts. I'm going to let Michael go through the next section. And again, reminder, please put your questions in the chat. We'll be responding live.
Yeah, thank you, Vikas. And for section 3 here, we're going to be discussing cloud architecture and go through some examples of what the current state looks like versus the future state in the cloud. So starting off, I'll just give an overview of some of the responsibilities of the cloud, as well as just some quick examples of what that might look like today versus what that might look like on the cloud. And so first, we can talk about data sourcing. So in the current state, companies might rely on internal systems to gather data, often dealing with siloed or fragmented information. But in the cloud, data sourcing can really become seamless. So cloud platforms, they can aggregate data from virtually anywhere. So that could be on-prem databases, um, really anywhere on the Internet of Things or third-party APIs. Whereas right now, in the current state, we're really just sourcing a lot of data from flat files into Excel. So on the cloud, we have a lot of scalability and connectivity, which allow businesses to access really a vast range of data sources. Um, and so since we might still be sourcing from flat files into the cloud, we can automate a lot of the logic through cloud tools. So for example, right now in the current state, a lot of logic might be living in Excel. And like Vikas mentioned earlier, you might have something on the cloud like Azure Data Factory, which can really help with data sourcing. And you can have some sort of pre-built logic that is easy to follow and is automated for data sourcing. And now once your data is sourced, it's really rarely in a usable state immediately. So in the current state, a lot of companies are still stuck in Excel, which is comfortable, but it's definitely not optimal. So first of all, cloud-based data lakes and data warehouses can provide a location for both raw and processed data. And there it can be organized and tagged, which is super valuable. And for example, we can use a tool such as Databricks to achieve this, where again, instead of having to do this manually in Excel, you can use Databricks to have some sort of automated process that does this for you. And again, this is super valuable because not only is it more efficient, but it's has much better controls and you can actually follow the process of how this is happening. So then there's data cleaning and adjustments, which is arguably one of the most crucial steps in any data workflow. And data that's messy or inconsistent obviously can lead to faults in analysis. And in the cloud, there's a wide range of tools to automate the cleaning and transformation of data. So in the current state, again, this is still a process that happens largely in Excel, but in the cloud, we can leverage tools like, again, Azure Data Factory or something like AWS Glue or Google Cloud Data Prep. And all of these tools provide robust data cleaning capabilities. And these tools are especially helpful when running large-scale data cleaning tasks because we can do this in parallel on cloud, really taking advantage of having a lot of compute power, which can significantly reduce time, whereas the compute might be sequentially being processed on your local machine. Lastly, here we have visualization and reporting. And there's a lot of cloud-based visualization tools. For example, Tableau, Power BI, or on Google, you have Google Data Studio. And these tools allow users to create interactive dashboards, as well as reports by sourcing their data in real time. And these cloud reporting platforms also provide a bunch of secure access controls, as well as collaboration features, which really just opens up the ability of what's achievable for visualization on the cloud, which really outweighs, again, what's happening in the current process, which is largely manual and in Excel. So now we can dive deeper into some of these responsibilities of the cloud, starting with data sourcing. So now we'll show some real examples. So here we can see how we source data today. It's a very manual process. So for example, data sources need to be accessed directly, and a lot of the time the data is copied. In this example on the left, we are sourcing data from a SQL server through a query that a user needs to update based on the current valuation date. So how this would work is we have an Excel workbook, we have a query pasted in there. If a user wants to access the data, they take the query, they update the variables based on whatever needs to be updated. In this example, it's valuation date. They go into their SQL server, they paste in their SQL query, and they execute it. And once that's done, they copy the data back from SQL into Excel. And the big problem here is that there's very weak controls. So essentially, once the data is copied, we don't really have a trail of where it came from. So a user opening this workbook will just see the number copied over. We won't really be able to trace it back. And if the numbers change, we don't really have a way to validate because of this. However, when we're sourcing data on the cloud, there's usually some sort of functionality that is pre-built. So for example, if we have a pipeline in Azure Data Factory, we can facilitate ingestion. So we can set up connections. So for example, we can have ODBC connections, which allow access between on-prem resources in the cloud. And in this scenario, instead of a simple copy of the data, we can actually view the data. So this means we're kind of looking at a snapshot of the database rather than a copied value from it. And this is some of the controls that Cloud Process utilize, which make for a much tighter and much more controlled environment. And in the same way, the users can trace all the steps their data has gone through, which minimizes errors. And also, since the process is automated, users won't have to deal with the manual updates needed in the current state, such as the manual update to the SQL query that they need to do before they run it to get the data they need. So moving on, next we'll talk about data storage. So how we manage data storage today can be very messy, which is usually just a result of the way infrastructures were set up before we had these cloud technologies. And because of this, in the current state, we usually don't have a single source of truth. So for example, here on the slide, we might have data coming through Excel files, which are loaded into a database such as Microsoft Access. And then we might source data from Access plus the Excel file into some sort of output or downstream process or report. And database structures might not be in place to house all the data needed for the downstream process, or storing data in the right format might be difficult due to the way the database is set up. But either way, we don't want something in this downstream process to be sourcing from a bunch of different places. Additionally, this will probably also lead to suboptimal data archiving. So issues like this would be, I don't know, using too much memory. It could take up a lot of space. You might not have all of the version history of your data. And then additionally, also then having metadata, you might only have file properties to look at. However, how we store data on the cloud is different. And with the cloud, we can negate all of these problems. So first of all, like Vikas mentioned earlier, cloud services have a lot of integration. A lot of the cloud tools work very well together. And because of this, we don't need to copy data. So we're actually able to promote a single source of truth. So for example, you could store everything in a data lake or in a Delta Lake. And you can think of a Delta Lake basically as an open source storage layer that sits on top of an existing data lake. And it provides a foundation for tables within the lakehouse. So we have all our data stored, and the Delta Lake can take care of some functionality, such as automatically storing version data. So this basically is a process which takes care of our data archiving. So we have this super useful control that allows users to look back at historical versions of their data, and they can also revert back to previous versions of data if necessary. This is also super helpful just in preventing any sort of issues, like if for some reason you have like data in a table that gets deleted or gets somehow transformed in a way that it wasn't supposed to, you always are able to revert back to older versions of the data, which is super, super helpful. So yeah, not only that, storing data on the cloud can also be more efficient, and it's also more scalable since you're able to really just choose how much memory you want.
Michael,
So
if I
next
can add
up,
one thing on the delta lake, the term delta comes from the fact that it's storing all the deltas of all the operations you perform on your data. So that's where the benefits that Michael spoke about come from, where at every point in time, every operation you do, it's storing the delta and the differences. And that's how it increases performance by having to store lesser data, but at the same time giving you the benefit of, I want to look at the data, how it looked like 3 months and 2 days ago. There you have it.
So next up, I'll talk about data processing. And in the current state, a lot of data processing, again, is done in Excel. So again, this isn't a knock at Excel because Excel can be great, but for some cases, the cloud is just much, much better. So for example, we've probably all experienced this example on the top left where there's some sort of complex business logic that needs to be done in Excel. So there's some sort of long calculation that has a ton of references. And looking at this in Excel is pretty painful. So just looking at like a quick glance at this calculation, you probably don't know what's going on. And as a user, you probably need to do a lot of clicking through the formula to find out where everything's coming from. So that's one issue with Excel. Again, there's also no modularity between the data sourcing and processing, whereas it's always going to come back to how the cloud is. There's a lot of connections between all the tools. You'll have your data and processing in the same spot, whereas here you might be sourcing your data from SQL, and then you might have some sort of complex business logic going on in Excel. Then within the logic or processing itself, you might also have a mixture of tools being used, which again might be harder to follow or even require more manual steps. And then also for the compute itself, like Vikas mentioned, if you have a lot of data that has to go through a lot of calculations and your machine doesn't have the capacity to do it, it can really shoot up the runtime and make doing these calculations or these logic operations super time consuming and long. On the cloud though, since we are able to outsource our compute, we don't have this issue. We can do all of our computations in parallel, which makes the runtime super quick. And as for the business logic, since we're not doing it in Excel, it might be a lot more readable for a user. So for example, if we're doing some sort of business logic, I don't know, in Databricks or some sort of other cloud tool, it might be a lot easier to follow and trace all the steps that are actually happening. Additionally, we have that modular functionality. So if we're using something, in this example, like Python, which is open source, we're really able to control basically all of the functionality that's going on and make it super modular. So maybe you can have some sort of process that can be reused in other processes if necessary. And then again, we have Apache Spark, which enables the distributed cloud processing, which is that parallel processing that instead of having this one CPU doing all of our compute, we can have multiple. Moving on to the final section of cloud architecture, we have data orchestration. So this is basically going to cover how we basically run all of our workflows and all of the logging and monitoring that comes with that. So in the current state, there's a lot of manual steps. So you might have to manually source your data, manually clean it, go through a manual review process. If something fails, you might have to go back and go through the whole process again, which if it's already super manual, it might be super time consuming. And then going back to a lot of the reasons that cloud is more efficient for data sourcing, for example, all of the logging information and data control and versioning. Monitoring, logging this manual process might be super painful, and it might be hard to follow, and it might be bad for like auditing purposes, for example. However, on the cloud, since you can automate a lot of the steps, so for example, that first example on the top right, you can automate pipeline triggers. So instead of having to manually kick off a process when data is ready, you can have some sort of trigger that sees the data is ready and kicks off the process right away. And then within that process, you can have the embedded monitoring logs. So each step along the way might output some sort of audit trail that is produced, and you can just you can look at it. You don't need to produce it yourself, and it'll keep track of basically everything you need, all of the timestamps of all the processes, all of the data that's going through all of these processes, and so on and so forth. And lastly, we're able to have these dependency trees. So for example, if you have a bunch of tasks that rely on each other and one of them fails, it's easy to go back in the dependency tree and see if there's some like upstream process that caused this failure, and have some sort of automatic rerun set up if necessary. And that way, since we have all of these processes in a modular fashion that are all automated, it makes the whole entire process overall much more efficient and easier to trace.
Michael, before the demo, if you go on the prior slide, so in this last section, you would have seen a lot of logos and terms being used of products or services on the cloud that relate more to Azure. That we just chose one of the two cloud services that most life insurers use, either Azure or AWS on this presentation. But there are parallels in the AWS world as well. So just wanted to highlight that this is the logos and the terms here are sort of like Microsoft Azure heavy, but the same services, same types of services are available on AWS as well.
Yep. All right, so now we'll move on to the demo, which we can showcase basically a lot of these cloud processes in action in a tool that we've actually built out. And Vikas, I'll let you introduce it while I pull up the tool.
Yeah, so everything you saw up until now and everything we've discussed so far is how to carry out these processes on the cloud, and how we do data storage, how we do data processing, how we do data orchestration behind the scenes. But what does a solution really look like when you have to put everything together, right? So this is just an architecture diagram where it shows how data is moving. It's sort of like an architecture of how you can do post-actuarial model processing. So how data comes from an actuarial model, feeds a certain data source, whether it's on-prem or on the cloud, and then starts feeding, on this diagram, it's Microsoft Azure, but it starts feeding the cloud file management system. And you make it flow through certain stages in that process, where it undergoes curation and standardization. The Python and Git icons at the top represent business processes. So once the data is version controlled and you want to perform some business operations on it, you can actually do that in Python or SQL or your tool of choice. And on the right-hand side, you have consumption. So that's how, once you have created the data for the specific use case, whether it's financial reporting or forecasting or any other use case like accounting, any other finance needs, you could easily consume it from that one single source of truth. Now, in terms of the demo, the one thing that we haven't spoken about yet is user interface. So what we did is, this is a backend architecture, but we built a user interface on top of it that is connected to this architecture and allows the user to be abstracted away from this architecture, because the common actuary, the common business professional doesn't want to know this technical, or doesn't want to have to deal with all of these technologies. They just want a very abstracted user interface to perform the operations they need to perform and focus on analytics, focus on decision making, focus on review. So with that said, what we're going to demo is a user interface. And just to this diagram is just to keep in mind to show you how things are being managed at the back end from that user interface. So with that said, I think, Michael, you can start sharing the demo. And I'll just maybe add one more comment while Michael brings it up is this solution is again actuarial post-model processing and assumes that data has been produced by an actuarial model. In this case, we have liability data coming from an actuarial model? And what do you do after that? How do you carry out your financial reporting process?
Yep. So I will just showcase this tool and I will explain along the way how the cloud processes are enabling us to basically do all of the cool functionality that we can do within Finality. So what you're looking at right now is the home screen, and all of the functionality we have access to would be managing our workflows, which I'll run through, as well as managing reference data, doing topside adjustments, a review and approval process, as well as an AI chatbot. But really a bulk of the cloud processes that we use are within the workflow section. So to give an overview of what's happening here is our actuarial model has run and produced some sort of output. And now we're ready to use Finality to process this output by standardizing it into one singular data format, then enriching it by tagging on metadata, and then creating some sort of report out of that enriched data. And so what you're looking at here is basically all of the output from our actuarial model runs. And we have a bunch of data about it, but what I'll draw your attention to is the status over here. So the process here is we have our raw output, which comes out of the model. And then, like I said, it can be standardized and then enriched and then go through a review process. And how this works on the cloud is that once we have our raw data, this can be stored anywhere. So for example, right now this is being stored on-prem in SQL, but we're actually using the cloud to pipe it over to, we're using Azure Data Factory to pipe it over to the cloud. And then from there, all of our data storage and all of our data processing is happening within our cloud platform, which in this case is Azure. So to give you just a deeper example, I will click into one of the model runs, which we have processed using Finality, and I'll show you the history of everything that's happened to this specific run data. So first, the model produced the data on this timestamp, and we got this raw row here. And within Finality, what we're able to do is we're able to select the raw data, which right now in this step would live in SQL, and we're able to standardize it. And what this standardization step does is it kicks off a pipeline within Azure Data Factory, which takes our data from SQL and performs a set of operations on this data, which changes the format of it into a specific format which Finality can read. And this way, all we need to do is set up the standardization process for separate actuarial models, and then we're able to read them all into the Finality standardized format, and then all of the processing that happens from here on out is the same. So that's the first step. And once we've run that standardization and our Azure Data Factory has completed its pipeline, we now have all of our data within Databricks. So this is what we'd get now on our UI. We'd have this standardized row, which is the same data that was in SQL, but it's now standardized, and it's ready to be enriched. So what this means is we're able to enrich the data by tagging metadata against it. So this could be a use case. We could give it a description. We could give it an attribution step, an attribution description. And what the process is here is that our UI is calling Databricks, and we're running just some functions on it that are written in Python, which will add our metadata to our standardized data and then copy it into a new table on Databricks. And one of the reasons we're able to do this from the UI is because these cloud technologies, they have APIs which allow you to interact with them even if you're not within the tool itself. So we don't even have to open Databricks to do this. We can just call the API with a set of parameters that tell us that tells Databricks what preset workflow we want to run. And it'll kick off that workflow within Databricks automatically and do all the steps necessary for the enrichment process to occur. Now, once this is finished, we now get enriched row and finality, which basically shows us that we now have our data in a new separate table with metadata tagged against it. And we're ready to create a report. So what this would look like from the UI is we're able to upload some sort of Python or SQL script to our Databricks environment and run that script to make some sort of transformation on the data or create some sort of downstream table that we can use. And this could be pulled into something, for example, like Power BI, like I mentioned during the cloud architecture section to like do some sort of data visualization. And again, how this works is we upload a script to Databricks through the Databricks API. And then again, we can call that script through the Databricks API as well. So all of the compute, all of this process that's happening is through the cloud, through Databricks. Nothing's happening locally. And we're able to create a report like that. And after we've done that, you're also able to create a review. So essentially what this would look like, again, within Databricks, we have a table which keeps track of all of the outstanding reports and all of the outstanding reviews. And what this would look like, I'll show you on the UI, is something like this. So for example, we'd have a review that needs to get approved before the data is able to be used downstream. So in this example, I created the review. It went to the next reviewer, and then it goes to the approver. We're able to have a comment section here where all the reviewers are able to talk to each other. And we're also able to, one, have a link to the results in Databricks, but two, also have any external files that the reviewer might want reviewed. And one of the really important pieces of this process is that since each step of this process occurs within Databricks, we're able to create basically an audit report of all the steps that have occurred in this process, all of the timestamps for all of the pieces that have happened, and it's super traceable. So once your data has gone through the whole entire review process, you now have this locked data that can be used downstream, and we also have basically the whole entire trail of all the steps the data went through to get there. And that would be the whole entire workflow section, which really utilizes the cloud to do all of this computing and storage of data. So Vikas, do we want to walk through other steps of this?
Yeah, let's go to top sides.
Okay.
And then you can go to reference data management.
So
yeah, so there are a couple of ways we can actually add top sites through this platform. One is associating it with model run, but as you know, actuaries can also do independent top sites. Let's go through the example of associating it with model run. What this would do is you would go back to the same workflow screen, and then you would choose a run that you want to add top sites for, and you would just click on the add top sites button. So in a topside adjustment, actuaries generally may want to load topsides in two different ways. If it's just like a single topside number, then you can directly come here and actually add information. The way this works behind the scenes on the cloud is that the format of data you're seeing here, the columns you're seeing here, represent what our standardized enriched data model looks like behind the scenes. So when the user enters information over here, the data is appended to the model run data that was already processed. So you could enter a topside over here. You will have to provide your, you can provide it at any granularity. So the policy ID cohort is a granularity that you can add, but they're optional. You don't have to add it at that granularity. You need to enter a variable name so that the system can recognize whether this is a gap reserve, a stat reserve, or whatever else you want to add. Reinsurance type represents direct, assumed, ceded, so that the system can understand what it needs to do, especially when it comes to accounting. Time step period in case of projected financials, and of course, an amount column. So the other method of actually loading a topside is by downloading a template from here and doing a bulk topside. So those are also, yeah, buttons on the bottom right, where you can, if you don't have just one number, if you want to add an entire spreadsheet or like 100 rows of topsides, you just download a template from the system, enter information, and then upload it back. So again, so what Michael did was just upload a CSV file which had like 4 rows of topsides, and then this is what it would look like. You would submit it in the system. And then at the back end, when you're doing analytics, the data you'll see, you'll basically when you came to the screen, you associated it with a model run, right? And that's the ID at the top. So the top side gets associated with that model run ID so that when you're querying the data, you can easily see what came through the model and what came through the top side in the same model run ID. So that's the top sides feature and how we are coordinating with the database, how we are working with the database to store this information.
Okay, so now let's look at our reference data management. So here we're able to basically update and create mapping tables which are used within the process. So Vikas, I don't know if you want to explain this a little bit more. I'll show you how you can basically I'll quickly just say creating a new mapping table is pretty easy. It would be uploading CSV, which then gets stored in Databricks. And I'll walk through the update feature. And Vikas, maybe you can explain exactly how these reference tables are used within the process.
Yeah, so reference data management, like, actuaries love managing their own mapping tables. The need for something like this is really where in reporting, you might have external data coming through that you want to use in your process, which could be like very simple mappings. It could be like a plan or product level mapping that you need to include so that your report can contain certain values and certain variables that may not exist in your actual model run data. So this mapping tables, so the mapping table functionality here is to be able to not only add but also modify real time your mappings as you want to do reporting. So I'll let Michael maybe explain like how we can modify mapping tables over here.
Yeah, so for example, we have all of our mapping tables in the system here. We're able to access them. So for example, we're looking at the variable type table, which shows all of the different variable types we have and additional data about each variable. So for example, if for whatever reason we wanted to go in and change a variable type, we'd be able to just click in, do that, and submit a change. And this would need to go through a review process first before it gets approved, but users would have the ability to go in and change mapping tables if they needed to for whatever reason.
So the specific use case here, like you see the columns on the right-hand side, you'll see exhibit ID, exhibit column, exhibit section. For those of you who are well-versed with the statutory financial statement, you know that you have to sometimes create exhibit 5 as an actuary, right? Exhibit 5, 6, 7, all of those generally come within the actuarial purview. So if you had a mapping table where you had a mapping of each variable to which exhibit it belongs to, which exhibit column it belongs to, and which exhibit section it belongs to, then creating exhibit 5 using this mapping data and using your result set and joining them together is going to be very easy. You reduce the amount of time it takes to create exhibit 5 from days and weeks to like literally hours to do so. So that's the specific use case here. So yeah, so that was the entire platform. One thing that we did not go through is the AI chatbot. which just in the interest of time, we may not walk through, but think of it as a chatbot, which is actually asking questions of the data on your data lake on the cloud. So it's harnessing cloud AI power to ask questions of your results, which is a very interesting functionality because you can return responses that could describe your results, that could help document memorandums as we need to do year end, or it could even help with what if analysis. Now, making it do what if analysis is a little more tricky because Gen AI solutions cannot do math, but by trying to build a wrapper around it so that it can understand your prompt, do some prompt engineering, and return the appropriate responses, or in the back end, return appropriate queries that can be queried on the database and return the information is returned to you in a more structured and readable form is possible, but that requires some amount of development. But it uses cloud Gen AI power to to help make the life of an actuary better by asking questions. So with that said, we are at the end of the demo. We have one more small section to go through on the main presentation, which is just to give you an overview of the state of the industry. So let's bring that up. And as a reminder, if you have questions, keep putting them in the chat. We'll keep answering them live. So so this is just a few charts that we've collected from surveys. Silent is one of our main sources. Silent is an Oliver Wyman company. And it just shows certain trends in the industry. So I'll just go through a couple of these maybe. So what do life insurers and insurers in general feel about actually moving to the cloud? Now, in that top left graph, I want you to focus on the bottom four rows, which are uh, for life and annuities providers. And you'll see a similar theme in PNC as well. But in the life group, you'll see that for life insurers who are sized between 0.5 billion to 1 billion, where that's like direct sales, there is a lot of benefit in moving to the cloud. Like everyone said, it's really good, right? Whereas on the other hand, insurers with lower than 0.5 billion saw very little value, whereas insurers greater than 1 billion in sales up to 5 billion saw a medium amount of value. What's driving that response there really is if you're under 0.5 billion, moving to the cloud, you're not able to harness all the economies of scale because there is an investment in moving to the cloud. And if you don't have enough economies of scale, then you don't get enough benefit. That's at least what we read from the responses. Things are changing, things are becoming better, but this is what we saw. And then on the other hand, when you get to above 1 billion to 5 billion range, like when you're a very large life insurer or above 5 billion, you have economies of scale, but your processes are so complex that actually making the investment to move to the cloud for all of your complex processes is very difficult. And so the ROI sometimes is lower in that case. And just the amount of time it takes to move is large, which is why you see that kind of a response. Whereas there is a sweet spot that if you have the economies of scale and the complexity in a processes is limited, then it's a really good place to be. Another one on the right-hand side, top right-hand side, I'd like to talk about is basically what are you using the cloud for, right? Definitely using it as data storage for your data lake, using it for data analytics, and using it for compute, right? Those are the three top high. That's expected. But then one part of the story there is insurers are still the cloud is still relatively a new concept, right? It's maybe a decade or so old, and insurers have only recently moved to the cloud. So the maturity is still low, which is why you see data governance lower than the other items in there. But as we go on, you'll see that number rising because insurers have not yet set up data governance processes as much as they would like to. But then over the years, they'll start maturing and they'll improve data governance on the cloud. And maybe on the bottom left, just highlighting the key challenges there. Skill set, finding people who understand the cloud and how to operate services on the cloud has been a challenge. Hiring has been a challenge. And then organizational readiness is also one challenge that we as consulting practitioners see in the industry where a company goes through a cloud transformation, but the business is just not ready to adopt it yet. It's still very new to them. They're still not comfortable, and also related to the skill set. They don't have the skill set, and they are a little fearful. There is some amount of hesitation to actually start adopting the new processes because people, in general, want to maintain their current way of doing things and not wanting to change. So there is some amount of organizational readiness you may want to think about as you modernize your actual and finance functions. But with that said, I think we are now at the end of our session. So hopefully all of our responses to your questions have helped, and hopefully this entire session has been helpful to you in understanding and getting an introduction to the cloud, the power of the cloud, and where the industry generally is. So thanks a lot again for joining on the session. And if you want to reach out to us, you have our names. I'm Vikas Advani, Michael Hofbeck. You can reach out to us at any time to help you with your journeys. So thank you again.
Yep. Thank you.